Don't. Just don't. Hang on, I haven't got sent the alert out. I haven't even rolled my sleeves up yet. Like, this is an absolute shit show. Hello. Steak, Queco, Matthias, Harand, hello. I've made the bar at the bottom fully opaque. Let's see how this goes. I tried to change the font as well. I don't know if that's worked. AC, hello. All right. I am so unprepared for all of this. Julian, hello. All right. What's going on here? Does what it says on the tin. Nice. Right. Oh dear. What's going on here? This route. Why was my... Just noticed slight issue. Not to worry, I'm sure we can fix it. I've just noticed none of my... I've deliberately not made this big yet because I literally just started and just set everything up. But for some reason, I'm getting Clang D errors. So I'm just going to, whilst you can't really see what's going on, try and fix that. Oh, interesting development. I upgraded GCC because I'm using trunks. I do try and keep it up. I do periodically rebuild the Docker container, and I've just noticed that the internal version has gone to 17, so that must mean 16 is pretty imminent if trunk is now targeting 17. It also means none of my bloody tooling is going to work. Give me one second while I, as a professional streamer, fix my setup live. Let's give this a whirl. It's not looking good. It is not looking good. Why is it not looking good? I could try and revert to the old Docker container, but I don't really want to do that. This is my fault entirely. That's not what I wanted to be doing. Sysroot C++ 1700. So why is my Clang D? Oh, typo, classic, my fault. This will work. Yeah, nailed it. Right, absolutely crushed it, mate. Did I send the alert out? What's going on? Right. Yes, I will start. Sorry, I was just fixing my setup. Okay, bit of housekeeping before we start. Shorts. Okay, short form content. Super useful for finding new audiences for this kind of thing. However, I'm a little bit burnt out making shorts. Like, I have a pretty good pipeline, but it's still it's an extra step after streaming, which makes the streaming feel a little less fun and more like a job. There is if anyone wants to help out, then I think maybe more for the Twitch people. I think there's a way of like clipping stuff as you go along that you think might be interesting. If you think I have said something that is worth sharing to a wider audience, which is almost certainly not true, there's a room in the Discord. Click some buttons. I think I can give you like a little flair or something on Twitch. Like, I've not thought this through. However, a little bit of help will be great. Other than that, I will try and keep up with them because I've got a massive backlog to go through as well. Second bit of housekeeping is what did I do off stream? I did a little bit off stream. I wouldn't say too much, but as always, a little bit. Artist tag, yeah. If you want to be recognized as an artist within the community, then you could like do some free work for me. That would be out. No, I don't mean like that. But if you do find stuff that you think is interesting, anything that can kind of get it to me so I can just run it through my kind of DaVinci pipeline super quick, that would be grand. If not, don't worry about it. Okay, I changed my mind quite rapidly from last stream, because like last stream I was like, we're going to finish off the coroutine stuff, we're going to do the scatter gather awaitable, and all will be well. I thought about it and I was like, we don't, I mean, I was running whilst we're talking about this, don't need the ability to await on multiple awaitables yet, and because it's kind of a nuanced and slightly more complex task, I don't want to implement that until we need it, because I think it should be backed by real world usage. Doing it through unit tests and like trivial stuff is fine, but I think we need to wait till we actually want to do it. So I've opted, to not do that. What I have done then off stream is, and I'll show the code in a minute, is I have, I'm not sure now, I've married up the exceptions with the coroutines. So if we go to the await, it was quite mechanical and nothing particularly interesting. It's a little bit of a hack, so I'm not that proud of it. But there's now, I guess the only thing that would have been fun to see is now there's this, it's our first instance of thread local. So the static, within awaitable, there's a public static function that will give you a reference to a thread local exception pointer, which is an awful lot of words. Basically, an exception pointer is a thing that stores a pointer to an exception, right? It's just a built-in type. Thread local means every thread gets one, and the static means that I can just call it directly on the object. So I basically have access. Whenever any code calls this function, it will get the one dedicated for its thread. And then if we go into task, basically, when we get the unhandled exception, we basically just stick that current exception into the last exception, right? So this will automatically go into the right TLS, thread local storage slot. No, I'm just explaining why I'm not doing any more threading stuff today. And then basically, if we go back to the pump, at the end of the pump, after we've gone through all the exceptions, basically, after we resume, so the problem is, because the tasks, the coroutines themselves, have final suspend never, it means they automatically clean themselves up, which is what we want. So that's kind of the API, the interface that we want. We don't have to be manually worrying about cleaning up these task objects. It means you can't store the exception pointer within the task itself because it's gone. So basically, call resume. If immediately after resume, we now have an exception, right? That means the only way that could have happened is the coroutine threw an exception. We then use a little bit of CS14 magic with exchange to basically reset the exception and then push it to a thread safe queue. And then what main does is, because main always calls this function, after it's finished handling all the events, it goes through the queue and it will pop the file off the front and rethrow it. So this basically means we can transfer exceptions from a coroutine running in any thread to the main thread, rethrow it, and then the main thread machinery that we have, which has a top level catch, which prints the stat trace and all that gubbins, all kind of works. So again, a lot of words. And then I went on an absolute mad one and basically went and added const expert to all the missing stuff. So I don't know if you can see the commits in the bottom left here. Scene, camera, entity, render entity, key event, mouse button, auto release, the errors, utils, the formatter, and I think even I've got one that I've not finished doing yet, is all const expert. So yeah, I mean, like, here we can decide what we want to do later. For now, I'm just going to throw the first one and be done with it. There's more, if we want to do more smarts, we kind of have them all in a thread safe queue. So that's kind of all I did. And then I just went through and I just spent about an hour const exploring like all the things. So now I've kind of decided on a slightly new style. If it's const explorer, then everything is declared. Everything is declared in the top and then defined below. So we could put these behind an import file if we needed to, but yeah. So you still kind of got the documentation of the class at the top. You can see everything it does, but the actual implementation is further down, and everything is just like const export upload to. This is a Clang D error as far as I can tell because they're 100% used. All the maths is const explorer. All the exceptions are now const explorer. More importantly, as of C++26, which GC supports, you can throw from a const explorer context, which means the one of the main ones we were missing was I think there's in matrix here there's an ensure which will throw, so this could never be const explorer, but now it can. So that's nice. And this one as well, the row couldn't be const explorer because ensure could throw. This probably needs to change to a contract, but I'm going to do contracts probably live as a separate pass because that's a new C++26 feature that we're going to want to have a play around with. I don't know who Lazo Velko is, so what am I explaining? Was that the explanation, or would you like an additional explanation? There's kind of a couple of things, right? Like if you mark it as const explorer, there's more chance that the compiler can do crazy, like clever optimizations with it, even if it's not been evaluated in a const explorer context. The other important one is that by definition, you are not allowed undefined behavior in a const explorer evaluation. So by marking it as const explorer, I basically get a free undefined behavior sanitizer. And because of my weird setup with MinGW, I cannot run asan or ubsan. So this is a kind of way I get that for free. So the more stuff I can mark const explorer, the less undefined behavior I have accidentally written in, because the compiler will not allow it. So that's kind of a nice advantage as well. So yeah, like I feel like using more const explorer stuff is kind of being more kind to your compiler anyway, because I'm not smart enough to understand all the optimizations the compiler can do, but I'm given to understand that it can do more at const explorer time. If there is anything we can evaluate at const explorer time, then we get that for free anyway, and also we get the added bonus of it basically being a free ubisan pass. How are the compile times? They are what they are. The biggest compilation time is async, so I need to rip that out at some point. A third of the translation units that the whole project builds is async. Yes, you get the UB contract for free, right? Doesn't matter whether it's evaluated or not. You are not allowed to write a const explorer function that has UB in it, regardless of where it gets evaluated or not. It's a bit of a contentious point. Like, should everything be marked const explorer? Like, there's kind of the mantra that you const explorer all the things. I have const explored all the things that are kind of the leaf nodes of the I guess our kind of component hierarchy, right? So all the math stuff, all the scene stuff, anything that's purely involving just data, because vector and string and all that kind of stuff are const explorer. Those are all const explorer. When it comes to interacting with the platform, so any of the rendering stuff, like that can't be const explorer, like it's an absolute nightmare. And if you have to do like if const eval everywhere, the code is messy. So all the like base level components of the game, like I said, like the maths components and the entity and the scene and all that sort of stuff, that's all const explorer because that's just pure computation. I think that makes sense. Everywhere else, it's not. So yeah. Something, what have I done? Does he ever? Do I what? Do you use ranges? Oh, bloody love ranges. Like everything is ranged up the wazoo. I don't know if I've got, what's a good example of some ranges, from some ranges. There's a range. There's a range. There's some more ranges in here somewhere. Maybe this is not a good example, but like everything is, there's a range. Everything is ranged up the wazoo. Modules, I had to concede on. I really wanted to use modules. I was desperate because I've never really spent any time with modules to really form an opinion. And I was like, let's do a big project with modules. I could not get it set up with the tooling that I wanted and the build system that I wanted. I just kept hitting roadblock after roadblock. So I just sacked it off and figured I'd do it again and I'd revisit it again in the future. So sadly, no modules for this project. Maybe by the time we get to the next project, things will be better. They could not possibly be worse. Okay, right. So now that we've context-exported all the things and we are thread safe, exception safe. Oh, and I added some missing tests as well. So I added some tests for like concurrent queue, the awaitable manager. It's just boilerplate stuff that I don't think is particularly fun to do live. I just kind of I had a few hours. I just sat down and grinded it out. So let me show you what I want to do today, because we really want to be making like we don't want to be like charging towards physics, but there's something fun to do. There's something interesting. There's an interesting problem to solve beforehand. Ranges are better than loops because I think they express intent better. Loops, you have to kind of pass in your head and work out what the begin and end conditions are and the logic in between it. Whereas if you like take this, filter this, strip this, drop this, transform this, they are semantically, I personally believe they express intent a lot clearer. I think they're a lot harder to mess up. Okay, right, so we've got our scene, right? We have two clever scheduled coroutines going on here. You've got the flickering white light, which you can kind of see going on and off. I might turn that off later because it's a little bit annoying. But the one I'm interested in now is this red light. Can you see here that this red light pulses? The intensity goes up and down as it goes through our scheduler system. Now, the coroutine that does this takes a pointer to this light. And I was playing around with this earlier and I noticed something funny and I was like, well, this is going to have to... This is one of the driving factors for today's topic. What do you think happens when you delete this light? Yeah, Apple's going to be way behind on reflection because literally GCC supports at the moment. Hopefully FlatMap and Stack Trace too. So I thought crash. I was like, it's going to crash. Like I've got a pointer to something that I've deleted. Okay, any improvements on crash? Because I was surprised. I was hoping for a crash. There's just a few more minutes for people to digest this. What's going on? It is UB, yes, but how do you think? Yes, how do you think it manifests itself? I guess would be a better question. I know, because if I do a poll, I'd have to put the correct answer in. Right, so let's delete it. Did you guess that this green light now starts pulsing? Because I didn't. And then if I delete this, then I think one of the other lights, can you see it now starts pulsing? So what's happening is if we go to main, pulse light, this takes a pointer, right? So this is just an address in memory, and that is a vector, and it's basically as we've deleted something from that vector and it's shoved things further in, that pointer is now pointing to another light. MinGW because I want to use GCC because it has all the latest goodies. Yeah, I think eventually. Well, no, so it's undefined behavior, right? I couldn't get it to crash because the point light object is trivially destructible. The destructor gets elided. It's just data, right? So all that's happening is the pointer of the vectors is just moving around until the whole vector is cleared. That memory is still like allocated, right? You shouldn't be using it, but it's just updating some values in memory. So what? There's a problem to be solved here, and I think a much wider problem. It's just ones and zeros, mate. How does Clang compare to MinGW for Windows? I don't. In terms of it, what's your criteria? Like, what are you comparing on? Like, Clang has not great C++26 support, which is understandable because it's pretty new, but GC has quite good C++26 support for the things that I'm interested in. It hasn't got reflection, it hasn't got contracts, it doesn't have optional ref, it doesn't have context explorer exceptions, it doesn't have a whole bunch of stuff, and some of the context explorer maths, I think, which was in 23. So I'm pretty married to GCC now. Right, so what we have to solve a problem here, in that there's kind of two problems to solve here, or two criteria. One, we need the ability to query if something is still valid, right? Because we have to expect in this game, like, things come and go, right? Their lifetime begins, their lifetime ends, right? It's totally acceptable that someone deletes light, and then this has to know that it's been deleted, right? And then react accordingly. The other requirement is that a lot of the data still needs to be like compact, like tightly packed in contiguous memory. So we can just, because all these point lights is just a bunch of structs and a vector, and we just squirt that straight into the GPU. So we can't lose that, right? But also we need, like, a pointer can't tell you if, that's the fundamental problem with pointers, right? It can't tell you if the thing on the other end is valid or not. So, like, an initial first pass, you might think, oh, just use share pointer, right? And share pointer is absolutely terrible because it doesn't solve any of those problems, and it just introduces a bunch more. Because the share pointer will just keep the light alive, right? If I had a share pointer here and someone else deletes it, like, I'm still holding on to it. So I'm persisting the life of this poor point light that just wants to move on. And the other thing is you can't really have contiguous memory, right? You'd have a vector of share pointers, which sounds absolutely terrible. Plus you've got dynamic allocation, plus you've got the atomic reference counting. So share pointer is, as always, the wrong choice. What I think we need, or what I plan on doing, is some sort of handle-based system, right? So we no longer talk in terms of the objects themselves. Scene, we're probably going to own it all, is going to create a light when you ask for it and hand out like an opaque, like cheap to copy, like super cheap to copy handle, right? Which you can copy around and persist as much as you want. And then when you want to access the light or the object itself, you go to the scene and say, here's my handle. Can I please have access to the actual data? And then the scene will be like, sure, it's still around, here you go. Or be like, no, mate, jog on. So that allows us to query for the object, and then internally something still has to be a vector. So I was thinking quite a lot about this. And I found an absolutely fascinating article. I'm going to link this now. So ENTT is I'm not doing an entity component system. Don't pay no attention to these three letters. That is irrelevant to us. What I really want to do, though, is look at the internal data structure that this guy uses for his for ENTT, the ECS that he uses. It's called a sparse set. And it's really fascinating because you end up with two arrays, a sparse array and a dense array, right? You hand out indexes to the sparse array, that is your handle, and then the sparse array contains the index into the dense array. So the dense array, you always push and pop from the end, or swap to remove, right? But the sparse array can basically have gaps in it, and it doesn't matter. So you basically are going to add an additional level of indirection to get to this dense array. But because this points to this, and this effectively points back, you can use this to check whether the handle is still valid. So I think we're going to build, because like I've got some intuition for this, but I've never built something like this before. So basically, today is a data structures day. We're going to be building some data structures. We're going to build this in tests, and then hopefully integrate it at the end. Yeah, no, it should all become clear with tests. But you can have a sparse array, and then that is your abstraction over to the dense array. And the idea is that we can still always have access to this, so we can squirt this into the GPU. A handle will just be whatever we define it to be. It'll be just like an opaque type. It'll be a type through which the user can infer and interact nothing with. It's just like a key into the data. Because I did think about using flatmap, right? Because on the surface of it, flatmap solves this problem, because flatmap maintains the keys and a data vector, right? And you can always access that vector, the data vector. But the problem is, though, it's log n lookup. And so if this is happening every tick, and you had 1,000 lights, you're doing log n lookups every time. So it has to have order one. So we want order one access, and we want contiguous memory, and we want the ability to query if that thing has been deleted. And I believe sparse set gives us all those things. So I've been doing this for, I've been making these games for a year and a half now, and I'm pretty sure squirt is the correct term. Yes, yeah. So jog on means like sling your hook would be another one. So yeah, so we want to be able to, if I put it in pure British slang, we want to be able to take a butcher's to see if the light is still there, and if not, we want to sling a hook, or tell the code to sling its hook and get on with it. Let's write some code. So what a great question. I don't think I'm going to make this expose iterators or make it rangeable, because I don't want people searching through it. By people, I mean myself when I come to use it. Like, you get a handle, and that handle is your in and out. Do you know what I mean? There is no searching for other data. Like, if you haven't got a handle to it, then you don't have access to that data. So I'm going to keep the API super minimal. He does what with the butchers? Right. Source, probably core. So we're going to call this what? We're going to call this sparse set. Nope. Copilot, you can do one, mate. Slinky Rick. Okay, let's start with this. I know. Can you expose an API from inside the GPU and call it from the CPU process to manage light? So I don't have any control over the GPU, right? I mean, the GPU exposes an API, right? That's OpenGL. So that's all I have. And OpenGL is basically like squirt data in, and that's kind of it. So I have to apply, any bookkeeping is for me to apply myself. Okay, so let's start. Something like this. Right, this seems like a good starting point, right? It's going to be quite templated, this. So I reckon we're going to have... It's going to be templated on a thing, right? So we're going to be like, here's how you allocate the thing. Sorry, no, here's how you allocate. Getting onto that in a second. Here's the thing that we want to store. So this could be point light, right? As an example, this could be texture, this could be entity, this could be rigid body. It doesn't really matter, right? There might be some restrictions on like how copyable it is, default constructible, all that gubbins. But basically, like, a sparse set is going to have, this is going to be our interface to it. I think as well, I think it would behoove ourselves to be a little bit forward leaning here and do allocator equals stirred allocator t. Okay. Where's allocator live? Memory, or is it in new? No, memory. Okay. So that's kind of our interface, right? So, and then I think we're going to want to store some stuff inside it. So we're going to have include vector, and inside here we're going to have actually, before we even get into that, C stood def. We'll probably treat ourselves to C stood in as well. So let's do vector t stood size t sparse, and then dense. Okay. Is that right? DNSC? I'm going to be referring back to the article as we go through this. Import stood, if only. One day. Okay, right, so that's kind of it. We're going to have, I think we're going to need then as well the actual data. And then these will match, right? When CLI passing stream. That's some fun I did off stream. I might use that for this though. I guess as well, so first fun one. Got to get an allocator into here. This is the... But this allocator is based on T, and we need it to be size T. So we're going to have to... Oh, it's that rebind nonsense, isn't it? Third allocator, is it trait? Like rebind third size T, something like that. You can take an allocator and rebind it to allocate on a different type. But who can ever remember how that works? Because I don't want it to be runtime allocator. I've no need to be able to runtime swap between the same container type with different allocators. I want it all to be templated. Allocator traits. Class template provides a standardized way to access various properties of allocators. And then somewhere in here, rebind alloc. Here we go. Alloc rebind other if present, otherwise member type. So that's going to be rebind alloc. Template argument template type random must be type. Did you forget type name? Oh, isn't this that absolute horror? Isn't this where you have to write template? It's something like this. Did you forget type name? So that. Oh man, using hang on, I can get myself out of this mess with more templates. Using vector rebound equals stood vector. Bear with me. I've got this. Vector rebound stood size T bath. Yeah. No? Oh, I can't. You? Yeah, mate, it's just standard template code. Don't worry too much about it. But basically, we can given the allocator we've been given, which is bound to a type, we can, because C++ does allow you to break most rules, rebind that to a different type. I don't need to rebind it because this should just what this the whole point of this is we should just pass this straight through, right? This knows how to allocate objects of type T, and Vector will need to know how to allocate objects of type T. Whether it internally rebinds it for its own means is kind of up to this. You need this, by the way, because like when you have the map types, right? Std map that actually allocates nodes internally, but you give it an allocator of the type object, so it needs to rebind it to allocate, the full node. Vector rebind. Fine. If it keeps everyone happy. Right, we happy with that? Yeah, I have the reflection error here because ClangD doesn't understand reflection yet, so there's not really a lot I can do about that. It's all right. I'm doing some quite advanced stuff, so I wouldn't stress too much about it. Okay, right. I'm not going to quibble anymore. There should be no more quibbling. So we're going to want const expr sparse set. Let's kind of do the basic functionality so we can start running some tests. And then we're going to want something like const expr auto size const and always const the size t, right? And then const extra auto empty const ball. Does that seem like a good fair starting point? By the way, this is about as much thought as I've given it so far, so we'll see what happens. Yes, I did manage to fix the clang D. Expected is good when the contract states that the function can fail and it's not an error. Exception when you cannot meet the post conditions, basically. Yes. We're going to get all there, but I want to start writing some tests first. So let's do e test sparse set test.cpp hash include gtest hash include core sparse set test sparse set citor the true false. So you make mn no pqrs sparse set test cpp filter yes b sparse. Shut up, run. The bottom screen is overlapped by 2 pixels by the chat bar. Ah, yes. I will change that for next time. I will try. Actually, hang on. Does how's that? Is that better? So sparse. So when we do auto s equals sparse set int sure, assert equal s dot size 0u assert true s dot empty. All right, that should get us going. All right, and if we go to sparse set down here, sparse set template class t sparse dense data unqualified ID. Oh, hang on. Nope. What? Pretty sure that's right. Have I made like a silly typo somewhere? Bleh. This doesn't like my rebinding. Oh, hang on. There we go. That's the badger. Getting there. Probably need to imprint the rest of them. Would be useful. Haran, I will try and get around to a question later because it is an interesting one. But for now, I do apologize. I am trying to make my life as difficult as possible for the entertainment of everyone, least of all myself. Return. Oh, you know what? Treat yourself. I'll treat you to a range. Third ranges size. What I'll do is I'll put it on the dense one because I think that's going to be the one that we actually care about the size of. The sparse one could have a much bigger size, but that's not really the total number of elements we're storing. I'm referring to the ENTT blog posts, but I've not read the source code. Again, I think something like this, I think it's kind of fun to try and figure out myself without looking at too much prior art. Dense or data? To be honest, it probably should actually be data because dense is an implementation detail. Nailed it. Ship it. Right. Okay. So we're going to need to return a thing, right? So we're going to want to return a thing. Actually, we should also have some of the member types as well. So using value type equals t, I guess. Well, actually, no. Yeah, I'll keep that for that. I might want to change that. There is no difference between views size and vector size. It's just uses ranges in the CPO to find it. It means technically, if we ever changed this then to something else, then this will always resolve the empty, even if you use like a raw, like a C array or something like that. It's to be honest, it's a bit of stunt C++. Like you absolutely don't need that. Control AN and Control AP, tmux are probably the actual answer we're looking for rather than the keystrokes that I have bound. Let's do class handle. Okay. Handle is going to return to us. Let's do using, yes, like handle type equals handle. Nick, I'm glad you enjoyed it. Thank you very much. Right, so this is going to be opaque, right? The idea being that to the user outside, they're not going to be able to see any of the internals, but we, because it's an internal class, will be able to see it. So I think we're going to do something like std size t index, right? So the handle, remember, everything is private by default in class. So this will store the index into the sparse array, which will then get us the index into the dense array, okay? In this sense, class, because I want everything to be private, right? Because I want to hand out to anyone using this, they should not see any of the internals, but we still need to have some. So this will be default copyable, right? But if we define our own size t index, right, that should probably be like that. And actually, let's do this properly. All right. So this will allow us to construct that handle, okay? From within the parent class, I think, but definitely not. So basically, I don't want anyone to even be able to construct a handle. Like, there's no way you can get hold of a handle unless you've got it from the sparse set. That's the contract I'm going for. But it will be copyable, right? This should still have a default copy move, or move will be the same as copy, but copy operations and destructor. How did I learn to do this stuff? I mean, I've been in professional C++ dev for like a decade, probably more. So a lot of this I just picked up along the way, and a lot of it I spend my own time kind of learning and playing around with. I mean, this I'm figuring out as I go along. I think you need forward declare. Maybe, like, well, I'll let the compilers. Oh, yes, you're right. In fact, actually, then we could break my normal convention slightly. It's probably easier to just stick this up here. Normally, I prefer public and then data types and functions, and then, sorry, functions and data types, and then private data types and functions. But I think it's easier just to slap that there. Well, we could make it explicit. It's not actually going to matter, right? Because no one's going to be using this but us. And then we're going to want const expra auto operator spaceship. Oh, new one. Const handle const equals default. What is the small screen you have next to your enormous monitor? That's for chat. That's literally a small vertical screen I have for chat. That's why if you see me looking over here, I'm looking at you guys. Okay, so this will basically mean that the handles will be orderable and comparable. Like, the user won't know, the consumer of the handle won't know what it means for one to be less than the other, but it will be able to do that. So that's kind of what we want there. I think that's kind of it for now. We might need to have some sort of concept of a null handle, but I'm going to add that when we get there. So let's try and insert something. So let's do const expra auto insert. I'm showing whether I want insert or in place. I guess probably in place would be better. So let's do template class args, right? And then do const expra auto in place args dot args. Can't be const. Handle type. Something like that. Add element in camel case. Get out of here. It's not a Win32 function. I think that's what we want, right? So we can basically construct. You can just give it some number of arguments and construct it in place, right? So the other thing we could do is just take forwarding ref to 1, like push back, and then expect you. Is that nicer? The other thing we could do is do const expra auto in place value type value handle type and get a forwarding reference to it, and then forward that in there, which means you could just construct it in place as a PR value, obviously. Let's keep it simple. Let's keep it simple and use the complex one. Can I now stick this down here, or am I forced to do it in the header file because it be a template? Sparse set t allocator. Yeah, I wonder if I have. Do I have to do this in the header? Too many. That is true. I mean, it's not wrong. Fine, whatever. Just do it up here for the moment. I can refactor it later. I just want to make some progress an hour in and they've written any code. Yeah, again, like I'm assuming, so for my need, it's all going to be trivially constructible data. I might even make that a concept, like a requirement. But for now, I want to keep things simple. We can add complexity as we need to. I'm all about keeping things simple. Okay, so we're gonna do, let's do data dot in place back stood forward args so I'll get there in a minute. dot dot dot. No, wait a minute. No, because it unpacks it this way, doesn't it? There you go. So that will give us back the, this will now stick it in data. So our index into that is now index 0. Okay, so we can do const auto dense index equals stirred ranges size data. All right, okay. -1. Yeah, because there's one element in it, it'll be index 0, right? Because they're densely packed. Yeah, I suppose we could do that. I think we've done that elsewhere actually. So let's get the dense index. Okay, so we're going to stick that in there. And then we need to now put in that value into the sparse. So sparse. So then we're going to do const auto sparse index equals sparse. Let's see. Stirred ranges size sparse. Right, slap that in there, and then we can do sparse dot in place back. Actually, no, don't even need place back there because it's just an int, isn't it? So just push back the dense index. Right. So this is 0, right? Which means when it goes into the sparse, this needs to point to this, and then this points back up into that index, right? So then we do dense dot pushback sparse index, right? I think that's all the bookkeeping we need. 1ZU means size t basically, or unsigned long, or whatever it is. 20, 20 that? 20, 23? One of the two. Right. Okay, so that I think is the bookkeeping. Yeah, because you basically you swap and pop, right, and then update all the numbers, and that's how it basically works, right? Because you have that layer of abstraction between the index into the dense array and then the index you give people, basically. And so then we just need to return a handle type of the, hang on, I want to give people the sparse index, right? Because you want to, I want to give them this index, right? So when they come in, they'll know 0, 1, 2, get the 0, double check that those are still valid, and then get the data. Everything's a trade-off, right? So there is, like, it's order 1, but it's not necessarily cache friendly, but I think that's fine. Like, I think this is still probably the most, I think this is still a very efficient way of meeting all of our requirements while still keeping the data dense. Okay, so that's fine. Of course, there's no point in testing that. Like, absolutely useless to test this because handle is opaque. Views systems or views can just be iterators. Yeah, I'm not writing an ECS. I'm literally just writing a way of storing data in a contiguous way whilst being able to query whether the item is still there or not. We'll profile it, right? Like let's get an implementation going, and then we'll profile it, and then we'll see where the misery is. All I want is a small integer, like, well, sort of cheap to copy opaque handle that I can query for the existence of something. That's what I want. That's all I want. Everything after that's just busy work. Okay, so let's do context bro. Auto operator handle type handle now the standard implementation will be basically it's UB if you request something that doesn't exist, so you should check it first, but that's not what we want. This is where we will differ quite a bit from sort of these standard containers, is we want to query validity and get yeah, I'm thinking optional, but I'm thinking though, right? New optional reference. How nice would that be, right? How sweet would that be? You can get back a reference to the thing in here. So if I've got to mutate it, I don't have to make any copies. I don't have to pass back a pointer. I don't have to do any misery with that. I'm literally like, I'll have a reference to it or I won't. I think that'd be pretty sweet. Because again, we can impose restrictions through usage, right? My expectation is that only the main thread will ever add and remove stuff to these things, and then basically during the tick, everyone's just querying for that effectively that static data. Like data will basically be locked in the main sort of macro architecture until you get to the end, and then we'll queue up like inserts and deletes and then process them all in one go. I don't want to crash, right? That data might, like, the whole point is that someone might have deleted that light, right? This is I think this is the end like demo, is we have an awaitable which waits like 5 seconds and then removes the light, and then that pulsing light just gracefully handles it and terminates the coroutine and effectively deschedules itself. I think we're going to have some absolute misery around constness though. In fact, actually, this is going to get a little bit trickier now already, because I think what I'm going to want is this auto. I think we're going to need to do this for this, because I don't want to write twice. But I've got to somehow now make this const when this is const. Let's make it work on one way first, and then we'll see where we get to. So let's do. I'm trying to think how much error handling I actually want to do here. Are we going to assume that it's always... No, that's not. So let's do if. So let's do const auto sparse index equals handle dot index. Did I call it index? Index. Yes, I do. Okay, so then let's do if sparse index is greater or equal to std ranges size sparse. We're trying to work out if this is a valid state. I think we could, like, because I'm happy to throw an exception if you've done something that's totally wrong. Right, but I think for now, like, just wait, we can check all this later. So then we can do const auto dense index equals self dot sparse index, right? And then we can do the same if dense index is greater or equal to std. Because what I want to do is basically, if we've somehow in an invalid state through our misuse of the thing, that should throw, because that's an error. If we have generally queried certain data that doesn't exist, but that's the valid outcome, that's when you return an null opt. But I think for now, like, we can go back and improve that later. Right, okay. And then we want to do const. So how do we get the actual index into the... data, because what I now need. Oh no, wait a minute. That is the final sparse index, isn't it? So if we do, I think I've got an example of this somewhere. If self dot dense of the dense index, right, does not equal the sparse index, then basically what I'm saying is if this doesn't equal, it even says here that to know if an element is contained by a sparse set, you've just got to do dense sparse elements equals elements, right? So basically, if this number doesn't refer back to this element, then someone has moved it and potentially reclaimed it. Oh, gifted subscription. Thank you very much. How kind. Your sparse index is always size of sparse, but does sparse set is not map look up this. I'm not quite sure I understand your question. I'm sorry. So now we should be able to return. I really don't know if make optional works with references, but we'll give it a go. Make optional data sparse index. I think hopefully it might become clear when we test it, right? So let's do like in place get dense index for data lookup. No. Don't know. Let's see what happens. We're gonna have to go through all the constructing some of these cases is gonna be really weird, but I think we should be able to do it. Let me just see what happens first. So let's say s dot emplace 2. Okay. Call a private constructive handle. What? But handles are Oh, is the inner class not automatically a friend? There you go. Right. The child can see the parent, but the parent can't see the child. I think that's the rules. I think them's the rules. Unless you force your child to be a friend of the parent. Right, this is not the full test, but let's just see if everything compiles and this works first. Friend. Okay, we're absolutely crushing it. Right, now we're going to have to invoke another miserable template now, so let's see what happens. After this, we want to do auto value equals, hang on a minute, auto h, so actually was the handle, auto value, no, wait a minute, auto value equals sh. Oh, great name, great variable names there. No variable conversion. Here we go. Here we go. Here we go. I bet that just explodes in a fountain of beautiful errors. That's not too bad. Interesting. Make option was trying to do it as an int. Okay. Let's do optional value type ref. Obviously not going to work for const because you absolutely cannot be returning a reference. If you call it on a const thing, you absolutely cannot be returning a non-const ref to one of the internal members. But like, I'll try that in a minute. Okay, all right, so we can do that. Sorry. So we want to do cert true bang bang value. Okay. So check it has a value, and then we should be able to do I don't really like doing value opt, but I think that'll be fine. Optional ref is as of C++26, which GC trunk supports. So we should be able to do auto ref value equals, so we should be able to get the reference out of this, right? Assert equal value 2. Yeah, mate, I'm reflecting the shit out of everything. If you're interested, you can look at the YAML serializer, which is all reflection goodness. Reflection is great, like absolute game changer, absolutely love it. I just want to reflect everything. Okay, so that should give you a reference to that, and then what I think we should be able to do then is do like plus value, and then I think we should be able to do assert equals dereference sh and get 3, right? So create the set, stick in a value, check that we've got something in it, check that we can pull out a value based on that handle, check the value is what we expect, see if we can persist the referenceness of it, modify it, and then check that if we round trip that back, we get the value. I'm pretty sure that the option was kind of idempotent in this sense, right? As in, like, I don't need to check it's optional. The optional is still charged again. Right, okay. Now, because I think this is going to explode. Oh, no, of course you can't have a... So how's this going to work? It's only going to work if you have a const reference to set, isn't it? So let's do auto... Jesus. Const auto sc equals s const equals, because it can't be has to be non-const to start with, otherwise I can't stick anything in it. But I just, that templating code, like that return value is not filling me with confidence. So this should work. This should work. So if we go via this, right, that should give us the handle. So that already doesn't work. So that's good. That should give us that. We shouldn't. This should force us to be const, right? And then this shouldn't be valid. So I think this. If this compiles, I'll be happy. Which it won't. Nope, reflection is a first-class feature of the language now. 37 and 38 need changing. Yeah, I mean, to be honest, I've kind of tested them above, but sure, let's just check we are doing everything the const way. All right. The fact that this doesn't work is kind of terrifying. I bet I need deducing this on that. Although shouldn't it... Which one is it? S-const. H. Oh no, that is where I expect it to be. Right. Let's... Can we... I'm hoping we can just auto reduce the return type, because that gets rid of one thing. And then I think what we need to do is explicitly pull out this, right? Because you can just make that a template argument. And then I think what we want is something like using ret type equals type traits stud conditional t stud is const if s is const, right, because we can access the type of this, then if it is const, then we want const value type ref, else it should just be a non-const value type ref, right? FTA, obviously the value, obviously, and then that's worse. That is actually worse. I'm hoping we don't have to do this const expr. Like, there shouldn't be any need for that. We should be able to do it. We should be able to use it doing type deduction. No. I'm confident. Inconsistent deduction for auto return type null. That is the thing with null opt t. I wonder if it's going to be a dick to us about it. Because null opt, the problem is though, null opt, see, the issue here is null opt is a special type called null opt t. So now that we've got auto deducing type, it's going to be like, this could be a null opt t and this. So what we're probably going to need to do is bypass this, right? So let's just make this, let's just shift this up. Let's use RVO, mate. So what we should be able to do is do that something like stud optional ret type. In fact, actually, using opt equals stud optional ret type. Actually, no, I already don't like that. Let's keep it simple. Stud not. I think you can actually just default construct that, can't you? So that should now keep the return types consistent. So that should solve that particular misery. See what happens now. Just throw it, mate. You can throw any type you want. Is that sparse set we need? Yeah, I mean the handle internally has the key, right? You just can't see it. Okay, not better, but maybe not worse. Right, here we go. What's this? No matching call for stud optional int ref value type. There are 15 candidates. Ref. Why is that saying there's no matching function call? See there, yeah, ooh, interesting. No, I don't want to remove the reference. If anything, I want to add it. But no, can you notice this is the const one, right? But it's deduced the type to the non-const one. So this is wrong. Oh, you mean remove reference on S? Yes, I bet you're right. Yeah, because I reckon S is deducing to S will be deduced to a const ref to the type, which we want to remove the reference to get the constness, because you can't. Const ref is not a type in of itself. You have a reference to something that is const. Let me prove that to you. I want to show you a neat template trick here. right? If you ever want to see the type in C++, define a templated struct with no definition, declaration only, right? And then what you do is you do debug s and construct it. That will automatically throw you a compiler error, right? Because it'll be like, can't do it, but it will always tell you what the type is in the error message. It's a way of forcing the type into the error message. And you can see here that in this instance, this will be from the, might only have the first, I bet it's failing at the first test. Oh no, here we go. Here you go, const ref. Yeah, it was const ref. Nice. Okay, that was a good spot. So by removing the reference, we can then query if the underlying type was const or not, because a reference itself is never const, right? You only have a reference to a const thing. That was a good spot. I think we would have got there with the debug trick, but thank you for saving me probably about 15 minutes of headbanging misery. So that's nice. And actually with the return auto type, now this just works. Like we've done it. Ship it. Loads of fun facts here. Okay. We have to do this somewhere else. Did we have to do this somewhere else? Yeah, when we were, again, deducing this, I should have known. Oh, is const v. I literally have the same code here to work out whether the internal type for the span should be const or not, based on whether the calling thing was const. I've already bloody solved this once. Yeah, now I've got to think really hard. This is the easy bit. Const export auto remove handle type. All right. Can't be const because you can't. So we don't have to worry about deducing this. Right. So basically, the way you do it is, I think the article even basically says how to do it. Is you. It sounds difficult, but it's not. In fact, actually, there you go. It's not too bad. You. Just after a moment, we swap it with the last one in the dense array and update their values in the sparse array to reflect the new positions. So if we wanted to remove, well, they remove 7. Notice how they swap it with the back one, right? And pop, which means your dense array is always contiguous, right? Because you've just swapped those two and then popped the last one off. So you're always going to destruct the element you want, but you've just moved something into its place. But I think the beauty of this is because we have the abstraction of the indices going through the sparse array, we don't invalidate anyone's pointer, like handle to us, right? Like if we just hand out indices to this, right, and we did a swap and pop, like people would have stale indices, right? So yeah, so it should be nice and it should be nice and easy. So am I going to want like the same gubbins here? Like I've got to check. I'm going to posit it is an error to remove something that has already been removed. I think that is absolutely a bug on the caller's side that we should be throwing for, right? If you try to double remove something, I think there's a bug in the logic somewhere, and I'd rather that exploded. So I think what we can do is we can take this and basically assess the validity of it, but we can do nope. Just pull the code there, mate. Core utils error. In fact, actually, I think these are just going to be expects, aren't they? No, ensures. So ensure less than that. Otherwise, we're going to throw invalid. And I might make handle printable, so there's still like an escape hatch for us to debug, even though the user should never know what's inside it. Like if they want to print it to a string and pass that out, that's kind of up to them. Like you could just memcopy it at that point. yeah, let's be strict, right? Because it's definitely a logic bug in the gameplay, I would say at that point. Where's the race condition? I can't see it. I don't think we're going to need a fully CS system. I think it's going to be way too much work for very little gain. Okay, so I'm reasonably convinced at this point. Yeah, if we're doing like a bullet hell game or something like that, or a factory simulator or something, maybe. But I just don't think we're going to need like a bajillion entities on screen. Right. So now that we're here, so what I need to do is I've got the dense index, right? I've got this. I do worry I've got wrong names now, because this isn't the index into the dense array. This is the value of the index within the dense array. So I might end up renaming some of these because I think it's going to get confusing, because we want to check, we want to stud ranges swap, right? The data sparse index, right? Because that's the one that's pointing to the actual data, with third ranges and data minus 1ZU, right? I don't know, like, usage of AI is somewhat inevitable. I don't use any AI on stream because the whole point is for me to have a vehicle to talk about modern C++ and to kind of showcase how I solve problems, whether they are the correct way of solving them or not. I use AI mostly as like a glorified search engine, so I will ask Gemini questions occasionally. I may use something if there's like if I'm doing something off stream, like I'll probably have Copilot on to tab complete like tests and do refactoring and stuff. So I wouldn't say there is like, it's not hard and fast no AI, but there's definitely a no AI like autocomplete stuff on stream, because that's boring. Like there's no vibe coding, right? Like I'm writing as much as I can. But like, I can't be lying if I said I've not like consulted the Oracle or used like Copilot to, I don't know, do some small refactor off stream. Okay, so then I need to do both, right? Because I effectively, in their article, they only have one, but I have to assume that I have one in parallel. So swap those. So we're going to swap that and then do data dot pop back, and then we're going to do dense dot pop back. Okay. It's fun. Like coding is fun. I enjoy coding. Like I enjoy like the template misery, right? It might not seem it at the time, but I find it very, I don't know, intellectually stimulating and fun to try and like produce the most horrific template code possible. Yeah, like taking legacy code and refactoring something modern, that's a great use of AI, because it's not a great use of your time. It's like, especially if you've got tests and a way of proving it works, like it's just mechanical, like it's just turning the handle, right? So use the machine to turn the handle for you. But for stuff like this, which is like it's not breaking new ground in the sense that I'm not doing anything massively novel in the graphic space, but like it's new to me and I'm learning a lot, and I learn much better by making mistakes. Right, so what we've got now is we now need to update the sparse array bookkeeping. Oh, mate, like I'm gonna have to have some sort of like there's gonna have to be some sort of punishment for keep mentioning Vulkan. So the old element is gone, right? So we can remove that index from the sparse array. So he swaps. Yeah. Oh, do you do the same in the sparse array as well? Is that... No, you can't. I can't mess with this order, right? Oh, but I can just delete it, right? Ah, I bet I set it to an invalid value. So if you come along with another one of those handles, it's instantly invalid. So let's do... const expra handle stored numeric limits size t max. So unlikely we're going to have this many elements, right? So we'll just use the last one as an invalid handle, I think. So then we can do the sparse equals... No, hang on. This is where it gets a little bit mind bendy. Sparse index equals inline static const extra invalid equals stored numeric limits the size t max, right? Auto, and then this will become invalid, right? And then equals handle type invalid, right? The stood optional add overhead. Overhead in terms of what? Space, time, complexity, like build time, like the answer is yes to some of those. But you'll need to be a little bit more specific so I can give you a fair answer. Okay, so that will now be invalid, but now we need to update the one that we've swapped with. Time, almost none, right? Like, inside it will be a anonymous union with a char-like option for like not charged or not engaged, and then the type itself, or because that makes it const extra, and then a bool which basically says whether it's engaged or not. So you will have to... No, there is no basically like runtime overhead, because you'll just be going through the anonymous union. So there's no like double dispatch or anything like that, because it's expected that you check if the optional is valid, right? Okay, so now I need to find the the old index, no, the one I've just swapped with now needs to be updated. Does that mean, yes, fine. I now need to find the sparse index. So sparse of dense index, right, has to now equal stood ranges size of dense. My goodness, this is going to go so wrong. Minus 1 ZU is now the last element. I mean, I think most users of Launder are wrong, right? Like, I guess if you've placement newing over something which had a const in it, but like placement new shouldn't need Launder. Need to update to the moved element 2. Yes. So that would be sparse of... Is it now the one that is at the back? I feel like this is just a swap, isn't it? Third ranges swap spar. No, is that right? No, let me do it manually. Let me just to convince myself it is. So sparse third ranges size dense minus 1 ZU. Dense index. What hell syntax have I? What have I? Stood ranges end and stood range size different. End will give you an iterator. Right, so I need to deref, but I want the value inside it. So this will give me the one past the end, rewind it by 1, and dereference it will get me a reference to the last element. Whereas size will just give me the index. So I guess you could do it either way. I just chose to do it that way. Oh, I'm trying to get some resource handles to work. I think I just need to write some tests and see where this explodes. Because I think as an optimization, right, we should push these then empty slots into a free list and then reuse them, because otherwise this sparse rate is just going to get bigger and bigger and bigger. We should be able to reuse these, but I think that's an optimization for another day. I'm kind of interested to see if we get this working first. Because then there'll be another list, right? We have another vector. We could have a free list. Yeah, Launder's an optimization barrier, right? It's basically like, here's a pointer, give me back the same pointer, but forget everything you knew about it before. Okay, so that's H2. So let's get H2. Let's try deleting them. Oh no, let's just keep it simple first. We'll do a more complex one in a second. So let's just check that H1 S in place. Right, we know all this works. Yada 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 yada. And then we should be able to do s dot remove h, and then we should be able to assert equal s dot size 1 assert, nope, not assert true, not s dot empty. Quite possibly. Well, we should try, if we think that's going to explode, we should try with this first. Because the problem with defragging it is I would be concerned that is kind of like a garbage collector, right? It's effectively, it's kind of non-deterministic. So when would you do the defragging? Like once per frame, once per time? You could be introducing additional like micro stutter in the frame. Whereas if we just keep a free list, we don't have to worry about it. That's kind of my very like initial uneducated thought on it. Yes, you're right. It should be empty. Across here, but once we've got loads of these, right? Well, I think it'd be conceptually easier to just keep a free list. I'd rather take a little bit more CPU space and not have extra cycles. I think. Okay, right, and then we should be able to do assert true that s dot a that this is not engaged. Oh, this is just me being lazy, right? Basically, you have value ops dot has value, right? That tells you Boolean whether it's true or not. It also has the Boolean operator overloaded on it, so I can just pass it anywhere which is contextually convertible to a bool. I could use it, so in an if statement. However, this will try and assert true that I suspect this will try and assert true that the actual object. I don't think, no, it's not always the case that whatever macro and magic that goes on, it calls the bool operator. So if you cast it to a bool effectively, right, by putting not in front of it, this will always engage the bool operator. But now I'm checking the wrong condition. Right, so if I then negate it again, I end up getting. I'm definitely going to get back whether it's values in it or not. It's just a little again, a little bit of stunt C++. The correct thing would be for me to type has value, but I'm just lazy. Boom. I think that's part of this their standard library implementation, right? I've done a bad thing. Yeah, I mean, I've static cast balls even more typing. I'm trying to type less, not more. Sometimes I indulge myself. It's not particularly helpful where this is occurring. So it's got to be one of these, right? So calling sh on empty. No, the test is fine, right? Yeah, that's fine because I need to be able to tell if it's there or not. Is that the issue? If it's gone, it's gone. Yeah, it did, didn't it? I suppose if the range is... Oh, I don't think I like this, but we could do self.dense, right? But this is always going to return... Like, there's literally nothing there. It's funny I didn't like it with this, though. Yeah, it doesn't like that. Right, hang on. Let me find out which of these it's not liking. So that should be fine. Or do I need to do it before I swap them? So that's fine. It's this one, isn't it? Because dense is now empty. I think I need to do if not stirred ranges empty dense. I need to pull the dense index before swapping. But dense could be empty though, right? So there would be, in that case, if you remove the last element, there is no bookkeeping to do. I think we need some more tests. Remove this. I don't know. I like ranges, and I think again I prefer more function. I prefer functional style coding over calling methods on objects most of the time. Yeah, this will not work with multiple adds and one remove. Okay, fine. So let's do multiple add, single remove. Let's do H1, H2, 3. Okay, and then we're going to remove H2. So this should be 2 elements, and that should be that. So let's just check this works first. Yes, I will add an assert throw for removing twice as well. That's fine. So, all right, so then we want to do assert. So actually, I want to do this in 2. I want to do auto h1 opt equals s h1. And then let's do assert true h1 opt, and then we'll do assert. Give these some different values, otherwise who knows what's going on. Assert equal star h1 opt 22. Right. This should not have affected that. Okay. And then we're going to do h2 opt equals h2, and this should be assert true that it doesn't have the value, right? Oh, I've seen it. I've seen it. I've seen it. Okay. All right, and then last one is three dot. Oh, literally pressed the wrong button. Absolutely ridiculous. Ridiculous. Right. So this is, so we've not correctly updated the last one, right? Because I don't know if I've got, if I can run the unit tests under a debugger, because I think it'd be easier just to see what's going on. Yeah, it's got that wrong. Can I run the Tests. Give me 1 second while I try and sort out my life. I think I can just yank that, call this USB1 tests, and then the test to see the workspace build test debug unit tests.exe, and then sparse set tests. Right, let's give this a go. Let's go down here and set a test here, and then let's see if this works. Oh, okay. Okay, I think we're doing it. Yeah. Okay. Well, I just want to see what's going on. Okay. This is how I approach the problem. So S has at this point 3, 3, 3, 3. So that has the data. That has 0, 1, 2, and that has 0, 1, 2. So those all map nicely, and presumably H1 has 0, 1, and 2. And then if we step in, okay, and then probably F10, over. Okay, so sparse index is 1, so that's the middle element that we're deleting. Dense index is 1, that is the thing that we want to remove. So we want to swap element 1 with the last one. So after this, right, data should have those swapped, which I think is correct. And then we pop that back, and then we do the same with dense. So dense now has those 0, 2. So now what we need to make sure is that sparse, those the indices into sparse are still correct, right? So if someone has a handle of this index, this 0 will go to 0, and that's fine. We've proven that. 1 will now go to... Currently 1 will go to 2, which is wrong. So we're going to make this one invalid. That's fine. So we've invalidated that. So if anyone now still has a handle of index 1 into the sparse set, that is now invalidated. So now what we need to do is make sure that anyone who has an index into 2, yeah, this now points, this has to become 1. And I assume that's not what's happening, because oh yeah, that's, that should be sparse for 1, shouldn't it? Because you shouldn't be updating. I'm using the size of dense in this sparse array, which is wrong. So that should be sparse. So that's one thing. Enough. Yeah, something else wrong here. Okay, fine. Let's run through again. Sorry, I can't think too. I got to fix each thing as I see it. I can't be doing too much at once. So after this, our sparse set is this, our dense set is this. So if you come along with, so it's actually quite nice, because if you look in these square brackets here, this is effectively the key we'll be giving out. So if you give someone key 0, you'll get index 0 in the dense set 0. That points back to 0, bish bash bosh. If you give the index of 1, this won't match anything, so you're guaranteed to get a null opt, so that's fine. And I think then if you try and double delete it, it should throw, but I can double check that. And then finally, but the issue now is if someone has given you key 2, this now needs to become 1. So this key handle 2 should point to index 1 in the dense set, right? And then, yes, you're right, someone said it, this needs to be updated as well to point back to that. So I think that's this one, right? So that becomes 1. So we now need to take the, this should be dense, that's why. So that should be dense, and that should point back to this index. Yeah, I think that's fine. So I think this just needs to be dense. He said. Writing data structures always sounds fun at the start. Right, okay, so let's do this. This fast. Oh, go away ain't watching shit. Oh, frickin' space. Right, thank you. Okay, so this is now valid. So anyone who has that handle is going to be told about it. Sparse now points to 1. So if someone comes in with index 2, they're going to get index 1, which is fine. And then after this 1, they're going to get 1. No, that needs to be 2, doesn't it? So this needs to be... Why is that not... Oh, does that need to be... Yeah, dense 1 should be 2, correct. So that needs to be... How's it going to know? It needs to know the... it should be sparse index? No, how does it know... How does it know what the new sparse index needs to be? How can it work that? How can it derive that? You're right. You just don't. Do we just not need that line? Okay, let's check this. So after this, right, sparse 0, 1, 2, into these go 0. If you get ID 2, you get 1. Index 1 points to 2. So that's all tickety-boo. I think we're going to have to write a load of tests to check all this, by the way. Like, I think there's going to be loads of misery in this. So handle H3 contains index 2, which... Why is that not working? So handle in a sense is index 2, self sparse 0, 1, 2 is 1, dense 1 is 2. So that should be fine. Oh, no. Where's that? Why is that wrong? That needs to be of sparse index, doesn't it? So in fact, it needs to be dense index. Right. Yes. Okay. Yes. Because dense index and data indexes should match. Okay, fine. So the bug is there. Okay, fine. So this should be... It's got lucky with one element, I think. Okay, fine. Let's try some more tests. Let's do remove first. So this now becomes that. Can't do that. This now becomes that. And becomes that. Okay, that's right. And then we should try removing everything, I guess, and putting something back in. We could try remove last. I think it's going to work. And then we need to do the double delete as well. Yes, it would be, but I've committed to this bit now, so that's what we've got. So equal star h1 opt 2, and then this should be that. Yeah. Okay, fine. Let me just check the double delete while I'm here. That paused right. Like, I'm not going mad. That definitely stuttered there. Maybe just the internal. I don't know what a cert throw does other than the hood. I mean, it should just want to try catch block, but right. Let's try yank 130. Try, I don't know, like complex, add, remove. Yeah, who knows? Right, so what do we want? We want something like a add, an add, and then what? S dot remove h2, and then like a auto h3 equals s dot in place. I know we already got that. Remove that, and then s dot remove h1. I want to end up with an empty one, I think. So let's add 2, remove that. Let's remove the. Let's add another 2. So add 2, remove 1. Add 2, remove 1, and then we'll do add another 2 and remove everything. And then after this, we're going to do s dot in a largely random order. Remove h5, 3, 6, 4. Right. We should have 6 adds and 6 removes. 1, 2, 3, 4, 6. Okay, and then for each of these, we're just going to do assert true s h1. Might have just about. Are we gonna have time to integrate this? Boom. Right. I don't waste the time. Right, let's see if we can fix this and we can save integrating it and doing some refactoring for the next stream. We're going to need to verify all this as we go along. Yeah, that's true. But let's just all right, S empty. Key 0 goes to 0, 0 goes back to 0, and data has object 2. Key 1 goes to 1, 1 goes to 1. Remove 2. So pretty sure I should be seeing an invalid handle in there, right? Zero goes to 0. 1 goes to that. Why is that not an invalid handle? Okay, fine. Try again. Okay, so we are removing this sparse dense data handle 1, so that's fine. So we're gonna this is all fine. We're gonna so this is gonna it's gonna swap the M1 with itself, isn't it? Then pop back. We could probably optimize that by not doing the swap if it is equal to the last member, but that's fine. Then range is going to swap. Sorry, dense is going to swap and pop back, so that's fine. So sparse index is now 1. So it is briefly the invalid handle, and then it's this misery here. Oh, I do need to know if it swapped with itself because there's no other bookkeeping to update. If it swapped with itself, then it's just disappeared and there's nothing to change. Let's do if data. No, let's do if sparse index is equal to std ranges size data minus 1zu, right? If it's equal to that, then we can just do pop, update that to index, and then return, right? That's like our optimized path. If you're doing the last element, just throw them away. Just throw those last two elements away and update the sparse index. I'm sorry, update the the sparse to be the invalid. Otherwise, you're gonna have to do swapping and optimizing and other checks and stuff. Okay, not quite there. Better, maybe. I really want to get these tests to the point where we're kind of happy with it, and then we can. I don't know. It's not going to take a whole stream to integrate this. So, but we need to start physics on an edge. Do you know what I mean? signal edge, whatever you want to call it. So might think of something small and fun to do for the next stream after this. Right, sparse. Yeah, I really want to add fog, like as a post-processing effect. Like that might be fun to add for a stream because it's going to probably be like another shader. I look at all comments, mate, and I do my best to keep track of them. The best way for it to be kind of triaged by myself is to stick it on Discord if you can. I appreciate that not everyone can do that or wants to do that, but I've almost certainly read your comment. It just doesn't mean I necessarily always. I'm afraid I just have. I'm at the point now with videos where I just do not have the bandwidth to respond to them all, and that's a real shame and something I'm not particularly like. I don't particularly like, but it is what it is. Right. So we're going to go here. We're going to pop that back. Going to pop that back. And we're going to set that to be that, and then we are out of here. So then we're going to push back. So this, what should really happen really is that this should have been allocated in this to be marked as in a free list, but we can because the free list is purely an optimization. Once we've got the tests happy with it, we can add that later and we'll know it still worked because the test will still work. But we've got to get to some working tests first. So stick that back in. Okay, so now you give it index key 2, you get 1 points back to 2, 2 gives you 200. You give it index key 3, 3 gives you 2, 2 points back to 3 and gives you object 2000. Oh, that could be true. Yeah, we could do that. Right, so now we want to remove H1. So that should be this one here. So let's step in, go through the step by step. So this is not taken. Right, so we're going to swap. Which one do we? Jeez, for sake. Handle 0. So we're going to swap 2 and 2000. Nailed it. Get rid of 2. We're going to swap 0 and 3. Going to get rid of that. We're then going to say index 2. Sorry, index 0 is now valid, which it is. The denser rate isn't bad. So hang on, I should have made a note of this. What were we pointing to before? So if you give me handle 3, 2000, right? Three now needs to point to 0. So 3 now points to 0, 0 points back to 3, and the 0th element is 2000. So that's fine. We then push back another one. So index 2, 0 and 2, 4 points to 2, 2 points to 4, so it's 1000. And then we're going to go key 5 points to 3, 3 points to 5, and then 20,000. It might be right. Okay, fine. Now let's see what happens when we remove them all. So we're going to remove 5 first, right? I'm going to step through this one just to check I know what I'm doing. So, hang on. 5, which is handle index 4. So 2 and so these should swap. Ooh. Ooh. He's not wrong. There is no 4th. Shouldn't that be dense index? And shouldn't that be dense index? No. It should be dense index, shouldn't it? Yes, because if the above one was sparse index, then they should have different indices. Okay, so another one here. Is this wrong as well? No, that is sparse index, because the sparse index is the thing in sparse that tells you where to point to. Both need... But have I not already done the lookup here? Is that not what this is? Or do I need to do it? Do I need to do it again? Data is sparse. Yes, sparse index. And this will be sparse index. Yes, because I need to get the actual index type. So I could... Okay, so now I've got my exception because I'm double deleting something. So this, which only comes from here, I need to see it in the test. I cannot parse this in my brain hole. All right, so let's just check all this. I've not massively balked all this. So S sparse. We've only removed 1 and 2, right? So that's those elements. That's fine. Okay. And H5 is 4, right? So 4 is looking at 2, 2 is looking at 4, and 2 there is 2000. H3 is 2, 2 is looking at 1, 1 is looking at 2, 1 is looking at 200. 6 is 5, 5 is looking at 3, 3 is looking at 5, and 3 is 20,000, whatever all the zeros are, and then finally 4 is 3, 3 is looking at 0, 0 is looking at 3, is the 2000 there. So that I think is fine. So it's going to be stepping in here. So what are we removing? We're removing, I've already forgotten the test, H5, which is handle 4. So handle 4 is 2, 2 is looking at 4, so that's fine. So this is not doing that. So this should swap. Sparse of sparse index. So it should be 4 of 2 of data with the end. So this should swap those, pop it back. Then this should swap sparse of sparse index. So sparse index was 4, going to get the 2, so it's going to swap 4 and 5, which it does, and then pops back. Okay, then it should set the sparse of sparse index, which was the 4, to invalid, and then it's not empty. So which one did we swap? We swapped with 5. Yeah, so 5 should now be pointing at 2. So 5 should point at 2, which it does. Okay. Step into this one. We're now removing handle 2. 2 is at the end. No, that's... 2 is pointing at 1. Yeah, why are we in here? This is now wrong. Could you not use the index in data? No, because I need to refer back. I need extra. I need metadata to refer back to the original index to check if it's still valid, and the data has to be absolutely as was given to me. If yes, this should be the dense index. Okay, fine. Yes, you're right, because I'm checking against data. I think that's probably good enough for us to throw into the game and start testing with. I'm not going to do that now because it's going to need quite a bit of wiring up, because we're going to need to find somewhere to stick our sparse set. We're going to need to put that into, that's going to need a wiring into scene. Scene might need a little bit of rework for that. I think there's more templates involved. I think that's, hang on, this needs to, that's kind of okay, isn't it? This needs to go at the bottom, right? 1, 2, 2. You don't need this validate, right? Because you just get an optional, like this is your this is your invalid, right? Because it's valid, like, because you're gonna get a reference back which is the size of a pointer. So like this is, I was positive this is probably pretty quick to check. Yeah, I don't know if there's some logic I'm missing in there somewhere, but yeah, I think this is kind of good. So that runs. Stick it in the git hole. Yeah, I'm not trying to implement an entity component system in ECS. I just want the specific data structure that particular ECS implementation uses. We have a check for empty after popping the last element. Do we? 3 new branch handles, because obviously we've not actually tried using the handles within the game yet. I missed that. Context. Just sneak that in there. Cool. Add sparse set and tests. Yes, I know I've got to get those. That's fine. 4, amend that. Put that. Stick that in the git hole. Oh, typoed that. Okay. Quite a lot done today. I'm quite pleased with that. We got to do some fun templatey stuff. We got to write some data structures. We got to write some tests. Generally, hopefully, a good time was had by all. Hopefully, you consider this a fair use of your Sunday free time, and I appreciate you for coming to spend it with me. What I will say now is that for Wednesday, so we will do this again, we will integrate that into main, because I really want to be able to have that light. I really want something else to delete that light, and then that coroutine gracefully handle it and effectively deschedule it. And then after that, we can either do the free list optimization. I really want to do fog, so I might have a little look at doing how to do that off stream so that we can implement it on stream. I suspect full screen post-processing effect, because of the way we have the G buffer, right? I imagine I probably have to do that after the lighting calculations. Slappy, it's absolutely fine as long as we're all having a good time. Okay, that's all I got. I'm gonna have a beer and hang out on Discord for a little bit, and otherwise I will see you all anon.